Okay, so what we're going to look at today is if we're given an angle side-side case, how do we figure out if we should have 0, 1, or 2 triangles? Last time we went through all of the cases of when do you have 0, when do you have 1, when do you have 2. We do not need to draw out the triangle and kind of try and imagine each case. We can just kind of do some work and it will fall into place for us, if that makes sense. So anytime you're given that angle side-side combination, it's going to look like the angle that you're given and its opposite side plus one additional side. Okay? If this had been capital C with little a and little b, it would not have been that big of a deal. We wouldn't have to do all of this ASS stuff. Okay? Okay. So we do have this angle side-side case, which means that we have the angle, the side across from it, plus one of the other sides. Your first step here is going to be to see, is it even possible for me to have a triangle here? Okay, so to do that, what we would need to do is figure out what would angle B be, or angle B or angle C, or A, I'm sorry, I'm saying this backwards. Angle A or B, one of the unknown angles, what would it be if it exists, right? So how can I find, well, first of all, which angle could I find? Could I find capital A or could I find capital B right now? Capital A, using which formulas? The law of sines. Remember that formula from last week was just a side over the sine of its opposite angle equals another side over the sine of its opposite angle. So you'll notice that here, if I wanted to find capital A, I would do the sine of capital A. What would I put that over? Yeah, little a, which is going to be 17.9 equals, and then I have both little c and big C, so I can actually write that value. Notice that when you're writing the sine of capital C, I don't want to have to deal with that degrees in minutes. So I'm going to write 75 point. Now remember that when we're converting this, we divide by 60. So what's 30 over 60? A half, so 0.5, right? We're going to put all of that over little c, which is 13.2. Okay, so all that I need to do at this point is multiply up by the 17.9 to get it off of this side. Make sure that what you're doing is putting, when you're punching this into your calculator is going to open a parenthesis, so you need to close it before you multiply by that 17.9. Make sure that you're in degree mode as well. Okay, so we get that the sine of A is equal to, so we get that the sine of A is equal to 1.31. What do you notice about this? Is it possible for us to have a sine value bigger than 1? No, this is out of range. So does an angle A exist? Is there an angle that will give you that sine value? No. So what does this tell you? How many triangles do you have? Therefore, no triangles. And there's nothing to solve for in that case. Are there any questions about why we can't find a triangle here? Okay, so that's going to work out pretty naturally for you guys. If no triangles exist, you're going to find it right away in this step because you're going to get a sine value that's bigger than 1. Okay? Can you have a sine value exactly equal to 1? Yeah, absolutely, right? That is going to be a possibility. So it's only if it's greater than 1 that you can say that there's no triangles. If you have a sine value equal to 1, what is the angle measure going to be? When does the sine equal 1? A 90-degree triangle, right? Okay, so keep that in mind as well. All right, let's look at the next example. Again, you'll notice that we're given an angle, the side opposite to it, plus an additional side. So this is an ASS situation. So we're going to start this the exact same way that we just did. So we'll start out by finding the angle that I don't know, which angle can I find right now? Angle B, right? So I'm going to have the sine of angle B over little b, which is 39.2, equals sine of capital A, which is 61.4, divided by little a, which is 35.5. So again, our first step is going to be to remove the 39.2 from this side, keeping parentheses clear on this side, times 39.2. Okay, so we get that the sine of b is equal to 0.9694, approximately. I shouldn't really be using a full-on equal sign here. I should be using an approximation. All right, so can I find an angle that will give me this degree measure? Yes? Yes. So let's find that. What do? Inverse sine. Are you going to use just these 4 numbers, or are you going to use the whole string that's saved on your calculator? Whole string. So we're going to write this in here so that I can see, where I'm getting stuff. But I'm going to use that whole string on my calculator. I'll go ahead and approximate angle B, though, to the nearest hundredth once I've actually typed in the whole value. I'm getting 75.81 degrees. Yeah? Okay, so I have this triangle, right? What can I find really easily at this point, now that I have angle B? Angle C I can find at this point. It's going to be approximately, how am I going to find it? Add everything up to 180, right? So we'll take 180 minus whatever angle B A is minus whatever angle B is. So 180 minus 75.81 minus 61.4, that's going to give me 42.79 degrees. What do I have left to find? Side C. How am I going to find side C? What formula? Law of sines. Yep. So we're going to use the law of sines again. I'm trying to find little side C, right? So little c over the sine of, I don't really have a choice. I'm going to have to use a rounded value here, except for the fact that, well, when I'm writing it down, but you could technically keep a string going on your calculator, right? And we probably should. But we get C equals the sine of 42, C over the sine of 42.79 equals, and then what would be the best one to use on this side? A. So the sine of 61.4 over 35.5. Oops, yep, you're right. I wasn't paying attention. Other way around. I need the sides to match the way I've written it. So I really need to do 35.5 over the sine of 61.4. To solve this, we just need to multiply up by the sine of 42.79. Again, always watching your parentheses. They're going to open parentheses on you here. You're going to want to close them. All right, so we get C is about 27.47. So have I solved for the whole triangle? Do I have all the angles, all the sides? Yes. The problem is that this right here is only one possible solution set. There is a chance that there is a second triangle. Why is that? Because think about when you're doing that sine inverse step, it's giving you always an angle in the first quadrant, right? So in other words, when they give you that 75.81 for angle B, that's right here. Where else could that angle still be and still be positive? Huh? Which quadrant? Quadrant 2 would still have a positive sine value, right? So this angle right here could also be a potential angle. How do I find that angle? Yep, so you guys are going to have to check this. You're going to have to do 180 minus the other angle, so 75.81. I kind of got myself smudged up in here, but we'll try that again. 75.81. What is that? 104 point what? 19. All right. Here's the thing that you have to check is that this is another this right here is another possible angle in your triangle. The issue is that if you take this angle and add it to your 61.4, sometimes these are going to add to be greater than 180. Is that a possibility? Can you have two angles in a triangle add up to be more than 180? If that happens, that's okay. You just stop. You say, all right, I checked my second angle and it does not work. It would not form another triangle. Do you see what I'm saying? But if you add them together and they still are under 180, then this is another angle measure that could potentially work. So what are you guys going to do here? You're going to check 104.19 plus your other angle measure that you know. What does it add up to? So if you were, in other words, if you were to have a third angle C, here, let me rewrite this because I'm kind of getting myself all over the place. We're kind of at this step right here now, right? We have another potential angle B right here. Sorry. So if I were to find another angle C, it would be approximately 180 minus the 104.19 minus the 61.4, right? So in other words, if you subtract all this stuff and you get a negative angle, you just stop and you say that that's not a possibility. Do we happen to get a negative angle here? Huh? So we get a positive angle measure of 11.71, which means that we get another triangle because this is a potential angle, yeah? So what's the last thing that we would need to find for this case? In this case, we have now all three angles, right? So we would just need to find side C for this particular situation. So you would do exactly the same thing. The only thing that's going to change is that your angle, instead of being 42.79, is now 11.71, right? That's your big angle C. And then you're still setting it equal to that angle A stuff. And solving it from there. Since we're out of time, I'm just going to say, you guys can solve that for C. But please notice that you do get two solutions. You get this solution and this solution. Make sure that you're clearly showing your work when you have two possible triangles. Make sure that I can clearly see here is one of my solution sets, here is another. Yeah?
So if the new C was negative, then it wouldn't be.
Right. If the new C was negative, then we would say, oh, that's not a possibility. But you at least checked it, right? So it is possible just to get the one solution. Or it's possible to get two. All right. It's posted on Schoology, so you can go ahead and look there. You don't need to write it down right now, but I'll leave it up in case you want it. This will be due on Tuesday.